All right. So round number X to 4 digits. So there's this is the first digit, the second, the third, and the fourth. So the 5 causes us to round up to the 7 to round to 8. So you would say rounded 1.468. So the
Okay.
absolute error is the experimental minus the true in absolute value.
Yeah.
So in your problem, the experimental is 1.468 minus the true 1.4675, like this in absolute value.
1.468. Oh, it's so I don't have to round it to the, like, let's say 1.47. No.
It says 4 digits. Digits means
Oh, 1, 2, 3, 4.
numbers.
Oh, okay. 1, 2, 3, 4. Because it's the significant figure, right?
Yeah, there's 4. It's really should say 4 significant digits, but it says 4 digits.
Okay.
All right. Do you have a calculator handy?
Let me see.
If not, I recommend using. Let's see if I can drop this into the chat.
She said we're not allowed to use calculators during any quiz or exam or anything.
Well, this is gonna be pretty tough to divide without a calculator. So, anyway, this is one that I give to students that don't have access to a handheld one. I mean, yeah, you don't really need one. It is 0.0005, but for the relative error, you will need a calculator. Maybe the idea is that the exam doesn't contain numerical problems. Not sure, or they're meant to be all done by hand.
It's gonna be done by hand. Yes.
Okay. All right. So then the relative error you get from taking the absolute error, the experimental minus the true, and dividing by the true. So you take your result from the previous problem and you divide it by the true result, 1.4675, like that.
Okay. And I'll have to get the answer for that, or I can just use that as an answer.
Well, you said you can't use a calculator. I don't expect you to do, but
Okay.
I don't know. This is a good question to ask your teacher in class tomorrow. Like, how am I supposed to do this without a calculator? Um, so it ends up being like, well, let me go to that calculator again.
4, 6, 5. Maybe 3.4.
Right. So yeah, so 3. We'll say 407, 4 significant figures times 10 to the minus 4. If you want it as a percent, which it doesn't specify, you would multiply by 100. Is that okay? Is that clear?
Okay. Yes.
Okay. All right. Okay, so the next problem, I either need class notes or I got to look the problem up because I don't know it right off the top of my head. Let me snip it in though. Sorry, I'm all over the place because I got too many things open. There it is. Okay, so the next problem, you're talking about some sort of computer. I'm sorry. All right, so I'm sorry. It's the same situation. Sorry. Suppose we do not have a true value X and approximate value X star. And equals 2.347 is 4 digits rounded number. Compute the absolute error bound for X star. Okay, so again, if we round this now to 3 digits,
It's gonna be 2.35.
yeah, 2.35. Okay, and then you take that number.
Wait, it says is 4 digits rounded number.
Yeah,
Okay, okay. Which is 3? So
sorry,
3.
sorry. No, we don't need that. I apologize. We don't need that for the problem. We just need, okay, sorry, we're not rounding this one.
Yeah.
So the idea is that since this is rounded, we don't know whether it came from 2.3465, 2.3474. Like any of those numbers would have rounded to this and anything in between.
So it's either that one or that one, right? Oh.
Well, it's a range, okay?
No.
And the idea is that basically you're off in this place right here, this decimal place way out here. So if you move your decimal once, twice, 3 times, 4 times, every time you move it to the left, it's a negative. So this is 10 to the minus 4.
Okay.
And we don't know whether we're off by plus or minus, which is essentially what this is saying. So it's plus or minus 5 times 10 to the minus 4. At least that's the way I interpret it. So when it says the absolute error bound, what that means is the true minus the experimental. We don't know the true, we just know that it's somewhere in here. We know the experimental is X star. You probably saw this in your book, X minus X star equals plus or minus, well, because it's absolute value, we could just say plus 5 times 10 to the minus 4.
Yeah.
Does that at all look familiar to what you guys are doing in class?
Took this, but like it was like the first thing we took, so I don't really remember. But like she posted up the notes on even the working questions and everything on D2. Like I can pull it out really
Sure,
quick.
sure. I mean, if you want, I can look too. We can move however fast you want. For the next problem, I need to like investigate what you guys are actually doing, because this is a little bit, it's strict, it's related just to this class. So give me just a moment. But this is how I'm interpreting it. I mean, it's up to you. Do you want us to spend more time looking at this problem or not?
Yes. I just wanna. I'm pulling out the lecture. If you want me to send it to you, or
I can grab it here on my side. So let me do that here. So is it under content for lectures? Lecture 0?
trying to let me see.
Lecture 0. Okay, here we go.
Fundamental of matrix annotated. Yeah, it's the fundamental matrix, I think. With this.
Fundamentals of matrix, you want me to look at?
Yeah, because she was working on this in the class. She was explaining everything using these slides.
This has nothing to do with what we're doing right now. I'm looking at it now. Matrices have nothing to do with this. So let me go back and look at, it was kind of in that computer number. Look at that one, I guess. There it is. Okay. Now there's also a
It's
practice
yeah,
practice problems.
yeah. I think it's practice for problems one. I think it's this one. Yeah. This.
Yep. See, there's an example problem that's exactly right, like what we wanted. So let's take a look at it. All right. All right. So let me grab it here. So here's your practice problem. It says they give you the true number 5.86593, and they give you X star 5.866. Okay. And then they say, okay, in part B here, which is kind of what we're doing. Suppose we do not have a true value and X star is 4 digits around a number, compute the absolute error bound for X star. So that's what we're doing. Now your instructor uses this notation, delta of X star, and that means it's always 0.5 times 10 E minus K.
Okay.
Okay. Now in this problem, K is apparently 4 and E is 1. I don't actually know why, but the answer that she gives is 0.0005.
Mm.
Okay. And that means for a 4-digit rounded number. So in our case, see how there's 3 zero, it's the 5.866. That's your 4-digit rounded number. 1, 2, 3, 4. They're saying it's off in the 4th decimal place. That's where this comes in right here.
Okay.
So the idea, this is correct, although they don't use pure scientific notation in your class. They use 0.5 times 10 to the minus 3 when you move it like that. So your instructor is using this notation of E, which I have no idea what that is. It's usually just an exponent. So you might ask what E is. K is the number of rounded digits.
Okay. Wait, so is that that's it? That's all I have to do?
This apparently is it. Yes, is this right here.
With that's for number one or two? That's
It's
oh,
for number 2. And I'll send you the notes at the end.
okay.
But yeah, if you need to get something done now.
I'm just taking a look at it. So I'll have to put 2.347 and put this as well, like to show my work as or
Yeah, I mean, I would. I mean, it's the
okay. And the plus minus 5 times 10. Do you have to do that, or that's not how she does it?
I don't know, Hamad. I mean, I was not in the classroom, so what I'm seeing is in the notes is
Okay.
this is my interpretation of it because I'm not in the classroom. But if you look at the slide that has this stuff on it down here, you can see her notation. Unfortunately, seeing it like this doesn't necessarily help because we don't know where stuff comes from, but um, E might be the number of digits to the left of the decimal. I'm really not sure. Be good to check with your teacher on that one, because that's her notation. It's not standard notation. So if you scroll up here, your teacher is looking for, your teacher wants you to recognize that in your problem, E is 1 and K is 4 again. And that's where this -3 comes from. It's 1 minus 4 gives you -3. Let me know when we can move on to the next problem.
Okay, I'm ready.
You're ready. All right. So the next problem here is to give the computational representation of these numbers here. So here we go. So thankfully your teacher gives us an example to go off of, which is really nice, because otherwise I don't know how you guys would know to do this.
This is-
The way the teacher says, so we're going to do this one over here on the left.
Yeah,
So for a negative number, you have to put a 1 here.
yeah,
And then you put the other number in to the right, and then you fill it in with zeros.
okay, okay,
Any questions on that?
no,
So for the next one, for B, you have to put it into scientific notation. But it's not traditional scientific notation. Because normally the number has to be bounded between 1 and 10, but your instructor says to write this as 0.717. And then you pretend like you're moving the decimal here, like 1, 2, 3, like that. So you move it 3 times.
okay, why just only 3? And why do I have to move it?
Well, because this is how computers represent numbers in your class. They
Hmm.
represent it as a number that's starts with the first significant digit. So these leading zeros are not significant.
And I
So you
can't,
go,
I can't put it like one more to the right, which is 7.17.
apparently not. And that would be a question I would be asking. It's like, why can't I do this?
Okay, okay, okay,
Okay, now, so you have 717. So that goes in the red, in the yellow here, 717. Because it's positive, you put a 0 here, and then you fill in other ones like that.
uh, okay, 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 okay,
Now the exponent here, because it's negative, you put a 1 here. The number 3 goes there, 0 in between.
okay, makes sense.
Okay, that's it for number 3. Let's go to number 4. All right. Convert the not binary number. So the reason that this is binary is because that 2 right there. That's how you know it's binary. Is that okay?
Okay, yeah,
So the idea is that, and you start from the right side here, so that you take this 1, and I know there's a lot of ones, but you take that first 1 right there, and you multiply it by 2 to the 0. Let me see if she shows it. Okay, they show it. She shows it slightly differently. That's okay. 0, 0.
Yeah.
Okay, yeah, yep, that's fine.
So,
So she's good.
anytime I see a 2 like this, it's a binary. Like let's say the
Yes,
65 and the 10. Is that binary as well, or
it's base 10 decimal, base 10, like we use. So that number in the lower right tells you what base you're in.
uh, every time I see a 2, it's a binary? Okay.
Yes.
Okay. Okay.
So binary, there's only 2 digits, 0 and 1. You're going this direction. So this one here, oops, you can't see it. This one is that first one
Okay.
plus 0. This 0 is this first 0. So times 2 to the 1. So you're going to notice that 2 to the 0, 2 to the 1 is going to start increasing, plus the next 0 times 2 to the 2. Then we have a 1 right there times 2 to the 3rd plus 1 times 2 to the 4th.
Okay. Makes sense. Makes sense.
Okay, so you got to be able to calculate all this. So this is 1 plus 0 plus 0 plus 8 plus 16. That's equals 25.
Okay. How did you do 1 times 2 to the 3rd? You do 1 times 2, then 2 times 3, 2 times.
You order of operations, you do the exponent first, then you multiply.
Yeah.
Let me know when we go on to 65 to the power of 10. Or base 10.
Okay, I'm ready.
Okay. So 65 to the power of 10, or I'm sorry, 65 base 10. You start with the number 65, and your teacher shows it this way. She shows what's called a factor ladder. Okay, so you divide 65 by 2, and this becomes 32 with the remainder of 1.
Remember this. Yes, yes, yes.
Then you divide by 2 again, it becomes 16 with a remainder of 0. 2 again, 8, remainder of 0. 2 again, 4, remainder of 0. 2 again, 2 with a remainder of 0. I'm getting off here. Just make sure I don't really like the way she's doing this, but that's you can have your own way. And then the last one there is when you divide by 2, you get 0 with remainder of 1. Okay, and then you go back up this direction. So the way you write the number is you actually start here at the bottom 1, then all these zeros, 1, 2, 3, 4, 5 zeros, 1, 2, 3, 4, 5 zeros, and then a 1. And then you have to put a 2 there to indicate it's base 2. 0, 1, 2, 3, 4, 5, 6. Okay, yeah, that is right.
Oh, there's only 5 zeros, right? 1, 2, 3. Okay.
It's a little bit awkward because you haven't used remainders in a long time.
Okay. Okay.
Questions?
No.
Okay, so that takes care of number 4. On to number 5.
Yes.
All right, let f of x equal x squared divided by y, and suppose x star equals 4.1 and y star equals 4, the approximations of x and y respectively. By the rounding methods, find the approximate absolute error bound of function f. Okay, so I'm assuming you guys had another example of this. You did. That's very good. Okay, so you have an example problem here, which is good to have. So your teacher's really trying hard to help you here. They're giving you a problem here. All right, to figure this out. I don't know if it's helpful, but it's that's what they've got. All right, so let me, rather than, I mean, I could explain this example and then explain your problem, or we could just go right to your problem. What would be best?
Could you explain this problem?
Yes.
Mm.
So best thing for me to do is actually to do it in pieces, and start with this. So the way this works is you first say, okay, delta x star is 0.5 times 10 to the e minus k. Okay. Now in your problem, e is the number of digits. So this is for 2.5. E is the number of digits left of the decimal.
Mm.
K is the total number of digits.
E is
E is the number of digits left of the decimal.
which is okay, one. Okay.
One. K is the total number of significant digits.
Okay. Makes sense.
So the idea is that you can apply those here. It's 0.5 times 10 to the 1 minus 3, 0.5 times 10 to the minus 2. Is that okay?
Okay.
Okay, now let me just look ahead here and make sure we're not doing anything wrong. Go ahead, pick partial derivatives. And then we have to evaluate at the number. Yeah, okay, so you don't need that. Then you do the same thing for delta y star. Delta y star is 0.5 times 10 to the e minus k. So you do the same thing in your problem. E is 1 because there's y star is one digit left of the decimal. K is 2, there's 2 significant digits.
Okay.
So this ends up being 0.5 times 10 to the 1 minus 2.
Okay. Which is
0.5 times 10 to the minus 1. So if you expand it, it's 0.05. On the other one here, it's 0.005, like that.
what's this? What's this?
What is what? Could you be more specific? What you're
Um,
referring to?
why did you change it to 0.005?
We're going to multiply. It's easier to multiply in this form.
Oh, okay.
Okay, so the formula for the absolute error, okay, the thing we're trying to find, the formula for the absolute error is as follows. Sorry, let me get that written down here. It is, you have to take the partial derivative of the original function and evaluate it at x star, y star with respect to x. Take the absolute value of that number. So you have to take a partial derivative, absolute value, and then you multiply by delta x star plus partial derivative evaluated X star, Y star with respect to Y times delta Y star.
That's the formula.
Yes. And keep in mind, if there's like a third variable, you just add on another term here. You have to take, basically it's, you take a partial derivative, evaluate it, then multiply it by this delta X star, which we already have, it's 0.005. Then you take a partial derivative with respect to Y and then multiply it by this 0.05.
Okay.
So we have to go back to the original function here. The original function is 2x plus y squared. So the partial derivative of this, the partial derivative of f with respect to x means to just look at the x. Derivative of 2x is 2.
From where did you get the fxy equals to 2x plus y squared?
It's given in the problem.
Oh, okay, okay.
All right. And then partial f, partial y is the derivative with respect to y. It's just 2y. But then you have to evaluate it at your x comma y that's given in the problem. So in your problem, it's 1.5. So it's 2 times 1.5, which is 3.
Okay.
So I know the notation is really confusing, but this right here is 2. Like all this stuff in the vertical bars is 2
And
times this right here. Question?
from where did you get the 2 again? It's from the x. Okay.
The derivative of 2x.
Okay.
So like coming down here, the answer is absolute value of 2 times 0.005 plus 3 absolute value times 0.05.
Okay.
So this is 0.01 plus 0.15, it's 0.16.
And the 1.5, it's in the question, right?
Yeah, they have to tell you that it's at 1.5.
Okay. Makes sense. Makes sense.
All right. Now we can go and do your problem now. It's basically the same thing, just now doing this. Okay, so we got to find delta X star, which is 0.5 times 10. And then there's one digit left of the decimal minus 3 significant digits.
Wait,
So this is 0.5 times 10 to the minus 2. This is for 4.10.
wait, this 0. Wait, the 0. Oh, okay. That's it's given 0.5 times 10 to the
Yeah.
1 minus 3. Okay, why is it 1 minus 3?
There's 3 significant digits in X star.
Yeah. Okay.
Okay, and then this becomes 0.005, and then we do the same thing, delta Y star for 8.0. It's 0.5 times 10 to the, well, so 8 has one digit left of the decimal, that's the E, minus 2 significant digits, 0.5 times 10 to the minus 1.
Plus 1.
So E equals 1, K equals 3, E equals 1, K equals 2.
Okay.
Let me know we can keep going here.
Yeah, I'm good.
All right, so the next thing is to f of x comma y equals x squared y over y, and to take a derivative. So you have to take a partial derivative of f with respect to x. All right, and this is so we might just kind of rewrite it here, 1 over y times x squared. The partial derivative of f with respect to x is 2x over y. And then you do have to evaluate it at x equals 2.5, y equals 1.5.
Um, and how did you get the x squared over y?
That's
This-
given. That's given
Okay.
right here.
Oh. Okay. Okay.
All right. Now to evaluate the derivative, 2 times 2.5 is 2.5. Over is 5, so let's do this 2 times 2.5 over 1.5. 5 over 1.5. This ends up being 10 over 3. All right. And then we have to take a partial derivative of f with respect to y. This becomes minus 2x over y squared. And then you again evaluate at the 2 points, 2.5 comma y equals 1.5. So this ends up being minus 2 times 2.5 over 1.5 squared. So this ends up being minus 5 over 2.25, which is, well, it's minus 20 over 9. Now to find your delta f x star comma y star, you have to take each of these values. So if you take that 10/3 absolute value, and then you multiply it by the delta x star, which is the 0.005.
Yeah.
Plus absolute value minus 20 over 9. Delta y star is 0.05. And you get some sort of result after doing that, which we can do. So let's get that number here. Questions?
No, that's it.
You feel like you could do this on your own?
Feel like I can I'll get lost after the X the
Okay,
one. Feel like I'll have to practice on that too.
sure.
Yeah.
Okay, I know it's been a while. My lessons are 50 minutes, so we've got time for probably one more problem. We'll stop at 250. So let's keep going here. Looks like next problem is maybe a matrix. Nope. Okay, 6 is,
How can I like the answer should be like this? Can I leave it like that, or I should
you're
like
asking the wrong person. I don't grade your assignments. I would talk to your teacher. You know, I don't know how you do this without a calculator. I mean, I'm really fast, and I
yeah,
mean, there's just not very many students that can do this without technology. So
I agree.
I'm not sure.
Um, she let us download this app called MATLAB. MATLAB.
Yeah. Yep. You know how to use MATLAB.
Yeah.
Okay. We don't really have, we could do 7A,
Okay.
come back to 6 another time. Just concerned we're not gonna have time to finish. I don't want to stop in the middle of a problem.
Okay.
So here's 7A. Okay, use Gaussian elimination to determine whether the following systems has no solution, a unique solution, or an infinite number of solutions. Okay, so one of the things I see right away is that, well, what you really want to do is you have to decide if you can combine equation one. By the way, this is equation one, equation two, equation three. Your goal is to eliminate one of the variables. All right, and I'm going to suggest that we combine these last two equations. Okay, now they want you to use Gaussian elimination. So to do that, you write just the coefficients in the problem here. Maybe you saw that in class.
Yeah, we were doing that today.
Okay, so what I do is I show you're going to take row one, or I'm sorry, row two, and add it to row three, and this is going to become your new row three. So we're going to take this second row, add it to this third row. It's going to become your new row three. The reason is everything cancels except for this last one, which is really nice. Okay, so this becomes 2, 1, minus 1, 1, 1, 2, minus 1, 1. Now we're going to add the two rows together. 1 minus 1 is 0, 2 minus 2 is 0, 1 and 3. Like that.
Okay.
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 Now we're going to take row 2, multiply it by -2, and add it to row 1. And this is going to become, well, we're going to do something else here. We're actually going to swap these rows. That's really the right thing to do here. We're going to swap the rows. So I'll just say that here or here. Swap rows 1, rows 2. Okay, so I'm going to do that down here. Copy. I'll just do it by hand. It's going to take too long. All right, 1, 2, minus 1, 1, 2, 1, minus 1, 1, 0, 0, 1, 3. So you really want a 1 in the top left corner. That's why we're swapping them. Now we're going to take row 1, multiply it by -2, and add it to row 2. This becomes your new row 2. And the reason you're doing that is you really want to get a 0 in this position, which we're about to have. So sometimes what students do is they show that off to the side here. They show the multiplication of row 1 times -2, -2, -4, 2, -2. And then I'm writing row 2 down here and adding them together. 0, -3, 1, -1. This right here is your new row 2. And so you replace row 2 with what you just found. 1, 2, -1, 1, 0, -3, 1, -1, 0, 0, 1, 3. All right, so really close here. We're going to take row 3 and multiply it by -1 and add it to row 2. This is going to become your new row 2. The reason is you want to get a -1 here, add it to this one, and then it goes away. So if I haven't lost you yet, this becomes
Like, it's a lot of steps. That's why.
sure is, yeah. All right, so let me just quickly, I'm just going to also just check that this has a solution. Probably should have done this first. This is where your MATLAB comes in. You would be able to test your answers or test that it worked in MATLAB using matrices. Yes, it's working. We're on the right track there. So the really quickly here, just because we're running out of time, 0, -3, 0, -4, 0, 0, 1, 3. So what this last row says, it says that x3 equals 3. The second row here says that -3x2 equals -4. You can solve that for x2. And then you can similarly do the same to find x1. It ends up being 4/3 as well. We just don't have time here to get to that. All right, so go ahead and stop.